Hello dear learner, welcome back to the Zoom Chemistry Hub. Today in this video we will discuss and learn the distributions of electron in the shell and orbital. So first we will discuss the distribution of electron in the shell and orbital by the formula. So in the shell, the distribution of electron according to the 2n square formula, while in the orbital the distribution of electrons according to the 4l plus 2 formula. So by these two formula we can distribute the electron in the shell and in the orbital. Now we will discuss how can we distribute the electron in the shell by using 2n square formula. So when we have first shell, that is the shell is represented by small n, and when the shell number is 1, that is first shell, then we have used the formula 2 into, we write the 1 here in place of n, and by square we get the number of electron, that is 2. So in the first shell there are 2 electron. So the maximum number of electron in the first shell are 2. Similarly for the second shell, that is n is equal to 2, then the electron according to the 2n square formula here we can calculate or find, that is 2 into, we write 2 here in place of n, the square of 2, then we calculate, that is 2 multiplied by 4 is equal to 8. So in the second shell, 8, the maximum number of electrons are 8. Similarly in the third shell the n value is 3, and we write 2 into square of 3, then we calculate 2 into 9, that is 18. So the 18 electrons are present in the third shell. So the maximum number of electron according to the 2n square formula in the third shell are 18. Similarly when the n value are 4, then we calculate 2 into square of 4 is equal to 2 into 16, we get 32, the maximum number of electron 32 in the fourth shell. Similarly in the fifth shell the n value is 5, and we write 2 into square of 5, then 2 into 25, and maximum number of electron in the fifth shell are 50. So by this formula 2n square, we can find the total number of electrons in different shells or orbit. Now we will calculate the maximum number of electrons in the orbital. So we use the formula 4l plus 2 for the distribution of electron in the orbital. For example, we know that when the L value is equal to 0, then the subshell is S, and here the number of electron in the s orbital we can write here by using the 4l plus 2 formula. That is, we have a formula 4l plus 2, and we know when the value of L is equal to 0, then the orbital is S. So in the S orbital we can calculate the maximum number of electron. Here 4 into the value of L, here is the value of L for S orbital, here is 0 plus 2. So we get maximum number of electrons in the s orbital are 2. Similarly, when the L value is 1, then the subshell is P, and for maximum number of electron in the P subshell we calculate here by using the formula 4l plus 2. Here 4 into, we write the value of L, here the value of L for P or subshell is 1 plus 2. So 4 ones are 4 plus 2. So the maximum number of electron in the P subshell or P in the P subshell are 6. So the maximum number of electron in the P subshell are 6. Similarly, when the L value is 2, then the subshell or orbital are is D. So by using this formula we can find the total number of electron in D subshell, that is 4l plus 2. Here the value of L is 2, and 4 2s are 8 plus 2. So the maximum number of electron in the D subshell are 10. When the value of L is equal to 3, then the subshell is F. So the maximum number of electron in the F subshell are, that is 4 into the value of L for F is 3 plus 2. So 12 plus 2. So the maximum number of electron in the F subshell are 14. As we know that the maximum number of electron in the S subshell are 2, in the P subshell are 6, in the D subshell are 10, and in the F subshell are 14. And we know that the number of orbital in the S subshell is 1. So S subshell have a single orbital, P subshell have 3 degenerate orbitals, D subshell have 5 degenerate orbitals, and F subshell have 7 degenerate orbitals. So the maximum number of electron in the orbitals in the two subshell, that is, we know that S subshell have a single orbital, so it contain only 2 electrons. P subshell have 3 degenerate orbitals, that is px, py, and pz. So the maximum number of electrons in these three are 2. Similarly, for D subshell, D have 5 degenerate orbitals, that is dxy, dyz, dzx, dx square, y square, and dz square. And in these 5 degenerate orbitals, maximum number of electrons are 2. So these 10 electrons are equally distributed in these 5 degenerate orbitals of the D subshell. And lastly, the F subshell contains 14 electrons, and we know that the F subshell have 7 degenerate orbitals, that is f, x, y, z, fx into x square, y square. Number 3, fy into x square, y square. Number 4, fz into x square, y square. Number 5, fz cube. Number 6, f into 3x square, y square. And number 7, f into x square, y square. And these 7 degenerates orbitals have maximum number of electrons are 2. So these 14 electrons are distributed in these 7 orbital equally. So all these 7 orbitals have 2 electrons each. So that's for all today, the learner. Don't forget to like, subscribe, and share this video with your friends and fellows. Thanks for watching.